All right, so hopefully at this point you've got a basic understanding of what we're trying to set up with MPLS, and we're going to take a look at configuring a Juniper SRX 220, or I guess in this case it's technically the Firefly virtual appliance, but basically the same thing, and that's going to get set up for communication with MPLS in an LDP type of setup. Now I've already configured the second ASA on this, so we're just going to walk through configuring one, but I can show you how to verify and sort of check these things. The first thing that we need to do is remove the security services from this device. Effectively what that is doing is making this work more like a packet switched or packet processed firewall versus a session oriented firewall where we're keeping track of all that and really watching the whole session, not each individual packet. To do that, what we're going to do from config mode is we're going to do a save. We're just going to put a file in the var temp, and we can just call it anything we want to. So we can do mic test CFG, just so when you need to restore those security services, you can get those back. So we save that out. What I'm going to do next is delete security. So that gets rid of all those services. Last thing I'm going to do, we shouldn't need to on the SRX 220, but just to verify that these things are gone, we'll do a delete groups global security. Okay, so it says statement not found. If we wanted to, just double check, verify it, do a show groups global security. Perfect, so nothing that we have there. Next thing that we need to do is enable the firewall for packet-based MPLS. So we're going to kind of walk through a little bit of that here, and then we're going to need to reboot before we can really configure the rest of this. So what we're going to do is we're going to set the security forwarding options to MPLS, and we're going to set them to packet-based versus flow-based, or that session-oriented style. Next thing we're going to do is actually enable my WAN interface for MPLS. In this case, my WAN interface happens to be gig000, so we can go ahead and set that up. So do set interfaces, GE000, I want this on unit 0, we'll do family, MPLS. Okay. The next thing I need to do is actually set the protocol MPLS up to be watching that interface we just created. So I'll do a set protocols. We'll do MPLS and say which interface we're going to be watching, which is GE000.0. Perfect. Now to verify that before we actually go through this commit and we go through the reboot, I'm going to do a show security forwarding options, and we can see we're in MPLS and it's packet-based. We'll do a show protocols, so just showing that MPLS is looking for that gig000.0, which happens to be the WAN interface. And the last thing we'll do is we'll just do a show interface and make sure that interface is actually set up for MPLS, and it is. What I'm going to do is I'm going to do a commit comment and say deleted security, set up MPLS, and once we commit this, it's going to give us a message just basically saying, in order for this to take effect, you need to reboot the router, and that's attributed to switching from the flow-based model to packet-based. All right, so there we see the warning message that we got. So as soon as it gives us our prompt back, we can do our reboot for that. And we'll need to do this from our normal sort of enable or privileged mode. So we'll just do a request system reboot, and that'll take just a minute. I've noticed with the virtual SRXs that sometimes when you do this reboot, especially after doing a request system zeroize to wipe it out, the VM will actually hang. So I can kind of try to point out while this is rebooting where that point comes up. But if it hangs, if you just reset your VM, it'll come back up fine the next time. So something to be aware of. All right, so this is the part it usually would hang at if you're going to have the problem. So just give it a minute or two. We'll see what it does, but if it does end up hanging, like I said, just simply reset the VM. It'll come back just fine the next time. Okay, so funny enough, mine actually did hang there. So like I said before, just reset it, started to boot just fine. So we're back to getting this firewall configured here. So I'm going to get logged back into it. And we'll enter into our command line and start going through that config again. So what we need to do is we need to configure IP addresses on the interfaces. Just so for testing, what I'm going to do is I'm going to create a interface that's going to be a loopback 0. And I'm just going to set up an IP address on it. So I'll do family inet address and do something like 200.001/24. I also need to set up the gig00 interface. So that's my WAN interface. And the network I had intended for this is, so we'll do family inet address 10.0.0.1, and the other firewall is configured as 10.0.0.2. So we've got our IP addresses set on those interfaces. The next thing is setting up an IGP protocol. I'm going to choose OSPF, just it's simple to configure and it works obviously quite well. So what we're going to do is we will go into, we'll do a set protocols OSPF area, we'll choose area 0, and then the interfaces we want to be advertised into OSPF. In this case I had two, it was LO0.0, and then I also had GE000.0 as well. And let's do a commit check. Let's make sure that we're still on track here. Perfect. So we'll keep marching along then and set up MPLS, and then we'll set up LDP with that as well. So there's not too much to it. What we have to do is we have to go back to our interfaces, and we'll go back to GE000 unit 0, and we'll set that up to family MPLS. We also want to set that protocol up again, so we'll do a set protocols MPLS interface and add in our GE000. Very last thing we need to do is set protocols LDP, and remember that's going to help us exchange those labels between routers. We'll set that up for GE000.0 as well. So basically just adding our WAN interface to all of those. Now if I've got this set up correctly on both routers, we'll do a commit check again, and we should be able to start verifying the LDP status. So I'll add a quick comment. And we can exit out of configuration mode and start trying to check out if we've got this thing up and running. So the first thing I want to do is do a show LDP neighbor. And we see that we do have a neighbor set up here as 10.0.0.2. We see which interface that we're connected with and the label space that we have as well. That's pretty good. let's do a show LDP session detail and make sure that this thing's actually open. So right now what we're getting is that we have a state non-existent or connection closed. So even though we see our neighbor there, for some reason or another, we don't have them communicating with each other. What I'm going to do is I'm going to quick go check out that neighbor and see if we can track down the problem. Sometimes it just takes a little bit actually, so there we go. Sometimes it takes a little bit for the LDP sessions to show up. So I guess maybe a little bit more patience and you'll see that come up as well. What we're looking for there on the top is basically that it's just in the state of operational and that the connection is open as well. Now if you want to see that this is working another way, you can do a show route table. And you'll see that we have two tables here. inet.0 will be your OSPF. So everything that's locally connected or OSPF is telling us about. If you do an inet3, that should be our MPLS and LDP table. So we can see that we've got an LDP route for the 200.0.1.1 network, which is the loopback on the remote router. What I should be able to do from this router is do a trace route to the 200.0.1.1 and see that we're able to get there that way. So things are looking good here. One last thing we could do to check it, I suppose, is just simply ping that. So 200.0.1.1. Everything is coming across well, so we're happy with that. And that should be our MPLS setup. Now, as you can see with LDP, there's really not too much to it. All of your ingress, egress, and intermediary routers are configured almost the same. The only difference you would have with an intermediary router is you'd be configuring two interfaces instead of one. Typically, our customers, the people on the edge, don't always have to tag their traffic when sending it to us. Just kind of depends where you want that ingress router at. So that is configuring LDP and MPLS, doing it a little bit dynamically.